Your website loads instantly for users in New York, but someone in Singapore is staring at a spinner. Same site, same server. The problem isn't your code, it's physics. A CDN, content delivery network, is a globally distributed network of servers that stores copies of your content closer to the people requesting it. Think of it like a library system. Instead of every reader traveling to one main library across the country, copies of popular books get stocked at local branches nearby. The content is the same, the distance is shorter. You get your book faster, that's a CDN. Your original server is still the source of truth. But the CDN puts copies, called cached content, at dozens or hundreds of locations around the world called edge servers. Without a CDN, every user request travels all the way to your origin server. Wherever it physically lives, New York to a data center in Virginia is fine. Singapore to that same server is 200 milliseconds each way, minimum. That's just the speed of light over fiber. You cannot code your way out of geography. For a startup serving users in one city, this isn't urgent. The moment you have users in multiple regions, it bites you. Slower load times, higher bounce rates, and a support inbox full of "your site is broken" emails from users in countries you weren't thinking about. E-commerce sites lose real revenue when load times increase by even half a second. Media companies serving video lose viewers. SaaS products lose trial conversions. CDN for beginners often sounds like optional infrastructure. It isn't. It's the difference between a product that works globally and one that only works near your server rack. Here's the actual sequence when a user requests a file from a CDN-backed site. A user in Tokyo opens your site and requests your logo image. Their browser sends a DNS query, basically asking, "Where do I go to get this?" DNS resolves to the nearest CDN edge server, a node in Tokyo rather than your origin server in Ohio. That edge server checks its cache. If the file is already stored there, that's a cache hit. It sends the file immediately. Round trip, milliseconds. If the file isn't cached yet, a cache miss, the edge server fetches it from your origin server, stores a local copy, then serves it to the user. Every user after that in the same region gets the cached version until it expires. That expiration is controlled by cache control headers. A header like cache control, max age, I86400, tells the CDN to hold that file for 24 hours before checking for updates. Setting this correctly is one of the most important and most misunderstood parts of CDN configuration. The two biggest CDN providers you'll see in production are Cloudflare CDN and AWS CloudFront. Cloudflare sits in front of your entire domain and handles routing, security, and caching together. AWS CloudFront integrates deeply with the rest of AWS cloud infrastructure. S3 buckets, load balancers, Lambda functions at the edge. Edge computing, a newer evolution, goes further, letting you run actual code at those edge nodes, not just serve static files. That's where the concept of an edge network starts getting genuinely interesting. And if this is the kind of thing you want to understand, Stack Future covers one concept like this every day. Both platforms let you configure behaviors, which paths get cached, for how long, what headers get passed through, and how to handle cache invalidation when you push a new deployment. You deploy a React app to an S3 bucket on AWS and put CloudFront in front of it. Everything works. Then you ship a bug fix, redeploy, and users are still seeing the old broken version hours later. What happened? CloudFront cached your old index.html at every edge location. Your new files are sitting in S3, but the CDN doesn't know that yet. The fix is a cache invalidation. In the AWS console or via the CLI, AWS CloudFront create invalidation. Distribution D your dist ID. Paths. That command tells every edge server to drop its cached copies and fetch fresh content from origin on the next request. Better long-term, version your file names using content hashes, so app.a3f9c1.js is a new URL every deployment. CDN caches the old file forever. The new file gets fetched fresh automatically. No invalidation needed. That's a pattern every front-end deployment should use. A CDN solves a physics problem. It puts your content closer to your users, so the speed of light stops being your bottleneck. The edge server, the cache hit, the cache control header, those three pieces explain almost everything about how web performance at scale actually works. Next up, how Docker containers work explained simply, what they actually are under the hood, and why the shipping container analogy almost gets it right but misses the most important part. If this clicked for you, hit the like button. It genuinely helps this kind of content reach people who'd find it useful.